Cool. We have Neil with us. Neil is a principal software engineer at Microsoft, and he was previously working with Salesforce. He's also a Google developer expert, so he has very broad knowledge on software engineering. And if you are interested in photography, I think Neil is also interested in photography, so feel free to connect with Neil on that. Neil, feel free to drop your LinkedIn ID if they wanted to have any conversation. They can do it also on LinkedIn. Yeah, cool. Over to you, Neil. Thanks so much. Thank you so much for joining. Yeah, the stage is yours.
Great. Good evening, everyone. Should I take over the slide or it's the same slide you have?
Yeah, you can take over it.
Okay, great. I'll just present my screen. Okay, just give me a second. I'm using Chrome after a long time, so it needs some of the permissions enabled. Should have checked that earlier. So let me quickly rejoin. It needs to be
Works. No problem.
restarted.
No problem. No problem. Cool. Guys, if you have any issues regarding SSK, you can ask those questions. How's your learning going on? Did you face any difficulties?
Okay, hopefully it should work. Mhm.
If it's in the Google Doc, please do share me on chat. I can share that like on
Okay,
what
I think it should come
can
up
do
right now.
that. Yeah,
Great.
yeah,
All right, let
yeah,
me go to the presentation mode. Hope everybody can see the slides.
yeah, yeah.
Okay, great. All right. So, hello everyone again. I am Neil Ghosh, and uh, uh, like you heard, I'm into photography and a little bit of stargazing as well. I had interest in astronomy a long time back, but my day job is as a software engineer plus programmer or architect, multiple roles I played in last 20 odd years. So I graduated back in the time when I think floppy was still in use. Uh, Probably pen drive already came in. I have seen the software engineering and industry coming from magnetic disk to the SSD and now the AI era. So I've seen the transition, and it's really great to see what's ahead in future. And all of you, I think, are already very good programmers and also write your code uh, with complex algorithms, data structures, and everything. But I just wanted to touch upon what I've learned in while working in the various companies in last 20 years, and how I was kind of shocked when I was introduced to new concept as and when I work. So it's not mandatory to learn everything already in today's 1 hour session or something. It's just to give you a heads up what is general terminology and general concept that usually used for a professional development in a production ready software, so that you're not surprised at all. You don't need to learn everything today. If you heard these concepts, you might just call back when you are introduced to it again at your work, and you might also get interested in something very specific and go ahead and read in detail, which you probably may not understand right away. So don't try to understand everything today, and or don't feel bad that something is uh, not clear, because it has taken me long time, and every time I touch a code base, I have to recall my memory as well. So when I started my career, obviously I was a programmer too. I was a computer science graduate. In fact, I later on I was a triple IT alumni. I took some of the courses from the information extraction and pattern recognition, machine learning, etc., from triple IT. So I'm quite familiar with the ecosystem. So uh, when I was a student or a solo programmer practicing for competitive programming or interviews, I would just write my code and be happy that the answer is matching the test and the program works. But and obviously this how fast I'm able to write is something I'm judged on, and still in interviews those are judged on how fast you write, because you have to complete the question in a certain interval. But when it comes to real world project and software industry, you really have to pay a lot of other things. Speed is not the only thing that will measure the success. You probably have to think about all the peripheral things. So coding is uh, very much a subset of the whole software engineering. It's probably, if I can roughly take the liberty of guess, 30-40% coding. Rest of the things is debugging, testing, talking to other people, understanding, deciding the architecture. And it's not just you who is working on it. You're working with the whole team. So it's very, very important that your whole team understand what you're doing. The other peers of yours understand what you're doing, and you understand what they are doing, because you're probably not going to write the entire software on your own. You have to collaborate with others. You work on a fragment, and that should be pluggable to the entire software. So it's not enough to run your code in a local system and just ship it. You really need to consider other things, like how will it behave when it is shipped in production, in which environment it is getting deployed, who are the users, are there a lot of traffic, or it's a small app which needs to be really, really accurate no matter what is the input. So there are some few things you need to really consider about trade-offs there. Uh, you cannot be super slow as well, that okay, I'll do everything perfect, I'll take months to ship it, but by the time you lose your user, your project shuts down because your company is not able to sell the software on time, your competitor comes and write the software that you are trying to build. So speed is also important, but then there has to be a minimum quality or stability that you have to guarantee, because let's say you are the first mover, you ship the software, everybody buys it, then it doesn't work as expected. It only worked in your local machine or a small scale testing. It doesn't work in a large scale. Then also there is a chances that your user will go away and it's not uh, get used. So uh, when you are working in a team, then there is a lot of redundant things that you have to work on. Like, for example, you have to rewrite a file, in your part, and your colleague has to rewrite a file as well. So both will have some utility classes that is reading and writing files. But if both of you duplicate the read write classes in your own system, when it is combined, sold as a software, you'll have a like 5 or 10 version of file reader and writer, and changing one thing will not be sufficient. You have to change in all 5 places. So we'll come to the dry principle. That's what it defines. How do you reduce duplication and make common classes so that it is reused? The another factor is, when you're writing your own software, you're free to use any library that you like. You chose a programming language that is cool these days, maybe Rust, and I have nothing against any programming language, but there are a lot of new technologies and libraries, especially the JavaScript libraries, keeps coming up and going without even people noticing. So it's very tempting to get the new library added to in your project and use it, but you have to really be careful that how long that library is going to be supported. Is it battle tested or not? Is it production ready or not? Somebody alone writing a library and you using it, tomorrow they stop maintaining it, then you're in a problem. You have to take the maintenance part of it, or basically you have to change to another library. So one has to be really careful. It could be a very old, boring technology, but sometimes it's wise to use a battle tested technology for a long lasting software. So uh, like I was saying, you are not the only one. One engineer is not the only one working on a software. It's usually a team of engineers which working on a building a software. So one the writing style or the coding of one person may not be same as others. So you might want to like to follow some certain standards, certain naming nomenclature, name the classes and methods in a certain way. The other person may be used to something else. So it's very, very important to upfront decide as a team what will be the standards. It's okay to disagree, but as long as the team as a group has decided a certain pattern of coding that should work for you. So there is nothing personal here. Yes, you might have to do some compromise because you are used to write curly braces in a certain way, and the team mandates or the team consensus is to write the syntax in a certain way, but it's overall more uniform is the code base, is more readable to you, because the software that you write, the code, the classes that you write might have to be debugged by somebody else tomorrow. Even you might move on to some other part of the software or some other company, the software lives on, right? So it's very, very important to have a verbose uh, uh, verbose syntax, and most important thing is writing. As a programmer, we don't really give a lot of importance to writing English, but if you see, writing is cheap. You can rewrite the text and paragraph or thought process very well, but once it is translated to code, it's very hard to or time taking to rewrite the entire code just because you missed something. So more you write, and be it comments, it doesn't have to be English paragraph, maybe it comments, maybe it tests. We'll see how test driven development works. It may be the function skeleton, or it may be a Google Doc or anything, but if you write the strategy what you are going to code upfront without implementing to the bottommost level, it is usually helps you thinking that are you going to is the thing that you are writing are correct or not. Because once you start writing code, and by the time you end, you realize a lot of things should have started in a different way. So if you write it down without starting, then it gives you a thinking model that, okay, I have still a chance to start in a different way, and I don't have to refactor or rewrite everything all over again. So uh, that brings me to the common practice that is done whenever you write a feature in a programming in a software. You write a design document, and the design document has certain sections that is really, really important. One is at the top, you always write the problem statement, what you're trying to solve. If you're not clear of the problem statement, if you're not clear what the software is about to be written, the rest of the document doesn't matter, or rest of the software, even if it is right, it's probably highly chance that it will fail. So if somebody is product manager or your boss or anybody who wants you to write a software, you need to be really aligned with that person, that it is written, the problem statement is written. Even if it's adding two numbers, you need to always uh, you need to define what does adding mean. It is adding one after another, like 1 plus 1, 11, or adding actually arithmetic addition 1 plus 1, because English can be ambiguous. So the requirement can be ambiguous. So it has to be really, really important to clarify things. And that's the same expectation when you appear for problem interviews, system design interview, because the interviewer always expects you to clarify the problems so that there is no misunderstanding in the beginning. So, and then it's usually important to have a graphical description of your, how to you trying to solve a problem, because it may not be a software that you're writing all along. Some of the component might already existing and you are just extending it. Let's say there is already a hospital, I'm sorry, a ticket booking system like Book My Show, and now there is a membership feature that is coming, gold member, silver member, or platinum member. So there might be already an architecture, so that should be written in that document, and where, which part of the software you are changing, that might be put in a different color or in a bold, that, okay, this is what is the new part, and it should play well with the existing parts. And both should be included, not just the new thing that you're deriving, because it may not be really compatible with the existing part of it. And the person who is reading your document next day or after 1 year to change something else, they need to understand how and why decisions were taken in a same way. So for example, you chose to use a certain language for your service, Java or C++ or anything, and there are multiple, usually there are multiple answers. There are multiple ways to do solve one problem. So you need to document all these options, because those mistakes or decisions doesn't need to be repeated again when somebody coming next year and trying to solve the same problem or a similar problem. They don't need to debate or really think why some decision was taken. It works as a decision log. And this document also clearly show not only just what is the problem you're solving, uh, the other non-functional requirements, in short, they call it NFRs as well. Those need to be figured out upfront also. It's really, really different to create a uh, software for a hostel and for the entire country. If the number of users are in millions, then the software design has to change. So your solution depends on what is the number of requests that is going to come per hour, what is the number of users that you have, or what is the expectation of the user. Should the page land in zero point 0.1 second, just like Zomato or something, or it's okay to land in 5 seconds? Let's say it's a examination result software or something. It's okay to give you 5 second delay and slowly load. So you don't pay attention or design. You don't have to really design in a way. So that is what exactly low level design and high level design. This is more of a high level design that you have to really consider. So now let's get into something which is close to your close to coding. So like I was touching base earlier, that there will be a lot of repetition when the software is written by different people. And even you, when you write two different piece of code in 2 different days, it's very easy to just repeat the file read IO, because let's say you were reading the file earlier with the absolute path. Now you are doing a different kind of software, a different kind of class, and you need to read the file again, but you see that relative path as an input is now much more useful. So, but it's expensive to go back and change the existing file IO API file classes, because the old software will break. But it's really, really useful to have a common place to uh, have the common utility function, so that you have only one place to change. Let's say something changes in the future, there is only one place to change. So here's an example. The left side, you can see everything. Somebody is trying to save an object to the database or file. So no matter it is user or order or everything, it is clubbed to a single class. But just because you don't want to repeat the saving, you have put everything into the single class. But this is not ideal, because you're sharing the logic between the domain in the dependency. Now, every time somebody has to create a new object, let's say somebody created a student object or a order line object, they have to come and change this class again. But in turn, if you have to, on the right side, you're saving logic at the central place, but it is agnostic of the type of class that is coming in. So if you see in Java, there is something called generics. That's what it uses, T entity. T entity means that T can be of any type. It can be a user type, it can be an order type, and the class knows the class knows how to save it. For example, here the database dot persist entity, it supports now all possible entities that is useful, that is supposed to be saved. Tomorrow a new object comes, for example, order line. The database API should already know how to do it. And for saving, you just need to call the save. You don't need to change the syntax of save. You don't need a generic object. You just need the save. this API can accept any type. Another example of here, you can you can reduce duplication of the code by you can reduce duplication of the code by having a common formatter. But this is bad because if this common formatter is used in two different places, for example, if you are showing this in a web page, then you need a dollar symbol. And if you're showing in a report, let's say a CSV file or an Excel sheet, you just might need a number, not a dollar symbol. But if you have a common method here, formatter, and somebody asks you to change the formatting on the web page, let's say instead of dollar, you put something else, INR or something, then because it is using a common method, the report class also will start rendering INR, and your some other functionality will break. Your CSV report, which is not in the UI, but internally it will break because it is using the same function. So you have to be really, really careful to have their own renderer functions, which knows how to render every object. The next is solid principle. This pretty much applies to object-oriented programming. So even if you're writing code in Python or let's say uh, any other language which is not really natively object-oriented language, I'm familiar mostly with Java or C Sharp. Those are the first-class citizen for object-oriented languages. In those cases, there are a lot of feature that these OOPS features that the language provide, like inheritance, polymorphism, or overloading, overriding. And so these features are very tempting to be used, but the solid principle guides us what are the constraints and in which cases you should leverage and in which cases you should not leverage the object-oriented concept. The first principle, for example, is solid, which is pretty much like a single, every class should have only one responsibility. It should not do a lot of things. So that from the class name itself, you know that what it is going to do. And it should have only one reason to change. So it might happen that the user service class have everything that a user related functionality can have, registering, sending mail, logging activity. But these things are very, very different reasons. Some, if you want to change the way somebody has to send email, then you have to come back to this user class. If you want something changed in register, again, you have to come back to this register class. And the practical example of a problem is you and your colleague are changing the same class, although you both are working two different features. And finally, when you try to both check in the code, there will be conflicts, and you have to again decide which is the right thing combined, which totally defeats the purpose of dividing the work and work separately and make things faster. So it's always advisable to have dedicated classes. For example, the user registration tells that everything related to user registration is inside this class. It can have members like email sender and logger, and the logic for the email sender and logger are in different classes. As long as as long as you are trying to send any email and log, no matter what email technology you are using or what logging technology you are using, you should be able to use the same class. The second one is an open close principle, which tells you the software entities should be open to extension, but closed for modification. When you say extension, it should be it should be giving you leverage to add new features. But modification is something the existing classes itself should not be changing. The good example is, let's say, payment service. You can have different kind of payment modes. For example, you can pay by credit card, you can pay by UPI or cash. But every time you add a new feature, let's say somebody adds a feature, you want to pay by cryptocurrency or PayPal, then you should not be coming and changing the same class again. And every time you change something, there is always a chance of breaking things. So a good way of doing this is you write a generic payment processor, and you write a generic payment service, and every time you add a new type of payment, you add a new payment processor, and that processor should have the logic how to process the payment. So a UPI processor or a credit card processor have two different logics, but because when you add a cryptocurrency processor, it doesn't really have to change the payment service class itself. You just create a new processor and pass it on. The class is responsible for invoking the process method of individual processor class, and it should give you the functionality without changing the payment service itself. The other one is Liskov substitution principle. This is basically, it tells you that how to, so object-oriented language has this feature interface, right? You have interfaces and you have implementation. But sometimes just because the language gives you the feature of having the method signature in the interface, you might be tempted to add every method into this interface and have an implementation in the subclass. The example here is ostrich is a bird technically, but so it should extend the bird, right? But bird has a feature that birds can fly. The problem here is all birds do not fly. If it's ostrich, it cannot fly. It runs very fast. So if you have the superclass as bird, then what happens to the fly method of ostrich? You have no choice. You just have to throw the error. But this is unnecessary. So the right choice of extending a superclass is only when all the features are already, all the features of the parent is with the child already. So a right kind of interface would be ostrich should implement movable. It should not fly. So although it sounds like technically bird is the right parent, but movable and flyable are two different classes that a ostrich or a different bird uh, like peahen should uh, extend to. Now, the other principle is interface segregation. Here also, it basically says the client should not be forced to depend on the method they do not use. So here also a similar concept, but it basically tells that not everything, the super interface, just because you can create interface for multiple classes, the interface should not be union of all the method that a subclass implementation has. So for example, here, take an example, you have a QA person who a QA person who doesn't write a code, and you have a developer who writes a code, and QA developer both are worker in a company. So you should not just union and add up all methods, write code and write test and create a generic worker interface and try to implement from them. So structurally, the code looks very good, but it's not a right thing to do, because when the QA's write code method is invoked, it doesn't have any functionality. So it's just a decoration and a good looking code, but by principle, it doesn't have any execution effectiveness, right? So you should have always the interfaces for only the methods that is implementable. So you can write for coder, for QA you should have a tester interface, and for developer you should have a coder interface. The last one is dependency inversion. This is very, very practical when you're writing code for different platforms. The one of the classic example is you're trying to generate a report and saving the file. Let's say you are using public cloud services, and in this case somebody is using AWS. So it knows that when you write a report, you need to create a S3 bucket. S3 bucket is a storage system is in AWS. Blob storage you can write files to, just like database, but it can take just binary files, images or zip files or whatnot. But the problem here is, here the report class is depending on a very specific implementation of AWS S3 bucket. there is no guarantee that in future you will not use something else. You can use Azure or Google Cloud Platform in future. In that case, you have to come here and change the logic, which defeats the purpose of abstraction. So the report class should only focus on report related logic, not what technology is using underlying. Here it is using the S3 bucket as a very specific AWS technology. Tomorrow it changes to Google, this class break. So you should always see the right side example. You have a report generator class. All the logic and business logic of report related things should come here. And the storage provider is a generic class. Now you can have a AWS storage provider or a GCP storage provider or a Azure storage provider. Even file storage provider, somebody is trying to write to the hard disk. So those can be part of those can be injected into this class, and as long as you call storage dot save or storage dot save, it should save to the corresponding location. It should save to the location, and it is one of the things that you can leverage while testing locally, right? Because when, let's say, you are trying to build a software in your computer first and then it will be deployed in cloud later in S3. So what would you inject locally to test it is a file provider, file storage provider, because locally you do not have the S3 storage. So your code doesn't change. Only thing you have to change while testing locally, you inject a storage provider which is talking to your local file system, not S3. So in that case, the report generator logic stays the same, and you can guarantee that your report generation logic is correct. It might fail to save while running in production because it is using a different technology to save, but your report generation logic is same in local and production. And this is very interesting. Like I was saying, uh, documentation is very important, and the documentation doesn't have to be really a Word doc or a text file, right? It can be a comment. It can be also the name of the method. So it's very, very important to choose the variable names, exactly what it does. Even if it's longer, the compiler doesn't mind elapsed time in days. I would, while writing a competitive programming or a short program, I would probably use it A, B, C, D, single letter. But because your code has to be readable and understandable by somebody else, it's really, really important to give a proper name. And you can, in fact, avoid writing comments by giving the correct name. And these practice also help you in feature these days. There are AI tools that creates uh, AI tools that understands and generate codes. By giving a correct name, things like it's not only helping another human, but also it will help the AI tools like Copilot or Gemini to understand your code better. So always, even if it looks large, it's important to give correct name. And so let's focus on about team culture. When you are trying to collaborate with multiple people in your team, you are not the only one. So your code will not just get deployed. Your code will be reviewed by someone. This is true for open source as well. When you try to contribute to a open source repo, your code will be reviewed by someone else. And that someone else could be an expert, could be a friend, could be totally unknown from a different country and culture. Remember, when you collaborate with somebody else with text, the text doesn't have the emotion, or text doesn't have the tone that you are trying to say. So it's very, very important and careful what you are writing, and what the other person is writing has to be interpreted correctly by you. So uh, whenever we are reviewing somebody's code, we have to be really, really empathetic about it. By saying that, I mean, the conversation should be around the code that is written, not the person who wrote it. One of the good comment is this class, for an example, this method might fail while dealing with null object. This is a very good comment. And the bad comment, you can write that you did not handle the null pointer exception. So that doesn't really sound well. Even if you probably said it in a lighter note, or your intention is not to hurt someone, but it may not come across in a person who is from a different culture, or doesn't even know you. So the conversation should be always focused on the thing that is being written, not the writer themselves, because they might be a newcomer or they might be an expert. The intention of a code review should always be that the author, you keep yourself in an author's standpoint. The reviewer is doing a favor to you by pointing out the mistake that would have been otherwise be done if he or she was not there. So you would have checked in the code would have broken, and it would have been a very bad thing to happen that your code did not work. But the reviewer is trying to help you here by pointing out the problems. Uh, it's very easy to say. In fact, there is a command called git blame, which actually gives you the history of a file. Unfortunately, it's named like that, but it's very important to not the intention not to be blame someone. It is actually you as an author seeking others' feedback, and it's your responsibility to correct it if you think the feedback is legit. Um, I think the focus point of code review or peer review should be always things like, is the input is validated, is because it's very easy to write code. A second pair of eyes always catches very obvious problems, and you should always take that as a positive thing that somebody else caught it, because it's literally impossible to be on a single frame of mind and catch everything. So these security and logic, these are some valid questions that you need to avoid, not questions like that, hey, there is an extra line, or there is a curly braces not formatted well. These are valid questions, but if your team, or if your tools, your ID is mature enough to catch this upfront automatically, this conversation will not even happen. You focus on important things like security and logic. So things like static analyzer, and there are other tools which you can configure in your IDE like VS Code and IntelliJ, which gives you a consistent formatted code and catches the problem early on automatically. So when you are writing a feature, you must be using some kind of source control system. Git is predominantly the most popular source control system, but it's not always that you uh, you merge to the main line. Git has a concept of branches, right? So you always take a copy of the main branch and create your development branch and keep on adding feature and then merge it back. So the outcome of the pull request review is basically merging it to the main branch. So one of the most few of the most important thing that it a successful teams do is always do smaller changes. Don't wait for weeks or months to build an entire feature, then give a reviewer, let's say 2,200 files, or uh, files in hundreds to review. And there are two disadvantages of it. First, the reviewer gets fatigued. They will try to avoid your review. They will not spend time that, hey, if I get into this, it's going to be taking me 24 hours or 48 hours to review the code. Let somebody else do it. If it's a smaller commit, they understand the code, they know the changes, and they review it. But in other case, the other problem is, even if they start taking review, by the time they finish the review, it is already too late, and you have been waiting for your feedback, and next time something else comes up and the cycle goes on. So avoid large commits, avoid large pull request. It's okay to not finish and raise a pull request in sometimes, because you can always tell that the feature is not complete. The code has to be written in a way. One of my earlier mentors long time back said, you have to be a ninja. So ninjas, when they do work, nobody knows that they've done the work. So it has to be a code that is sitting there, but it's not creating problems for others. And one of the great advantage of smaller pull request and smaller commit is that you get an early feedback. If you get a big bang PR and it get merges and it breaks everything, you will never be able to pinpoint what part of the code actually broke. So if you do smaller changes, you know that, okay, today it's broke. I know what changes, what was changed yesterday. It was just 5 lines of code change. Maybe there is a problem there. So when you are working on a large scale system, usually you and you deploy services in a cloud environment or a server. Generally, the production code, the production deployment happens on a separate branch. So in the main branch where you develop and merge to, it always incrementally goes on, but not every change doesn't make it to production immediately, right? So there is probably a weekly cadence or a monthly cadence where a stable version, well tested, cut from the branch, from the main branch is cut, called a feature branch. Let's say release 1, release 2, release 3. Or you can name those branches January, February, March, April. So let's say, for example, one of our team followed first week of the month, we deploy to production. And the rest of the month, whatever is coded, will be deployed in the next month. So there'll be a March branch, April branch, and so on. But what happens when there is a problem detected in production? So you cannot really fix the bug in the uh, current branch that is in development, let's say main, because if you try to deploy immediately everything that is in main, that is not well tested. It will fix the bug that you're trying to fix, but it might introduce a lot of problems as well, which is not well tested. So generally, in those cases, you do a hot fix. Hot fix is you copy the copy of the branch that is currently in production, you make changes on top of that and deploy to production and fix the issue. But with this, the problem is the fix that you made is not now in the main branch. So you have to merge it down as well. Technically, it's called merging back to the main so that next time when the main branch is deployed, this fix is not missed. In a very mature and advanced team structure, you might always do uh, a, a very frequent deployment where probably the main branch itself is getting deployed, but it has to be really, really mature that nothing that is being pushed to production is not tested or not covered by test, or you don't have an option to roll back. So we'll come to that. Let's say you have a system where everything that is being developed is immediately pushed to production. So good idea is always that the features should not start just working or reflecting in production immediately when you push. These two have to be two different events. You can push the code into production, but you decide the feature has to be enabled when. For example, you're doing something around Christmas holidays, some big billion sale. You can develop and deploy the feature back in, let's say the sale is in Dashera time, October. You can create the feature and deploy it in September or much earlier in July, but it doesn't mean that those features are already live. So all the feature has to be under feature flags. So feature flag is just a button or a Boolean configuration, which you can enable and disable without really redeploying the code into the production. For example, here the new checkout flow. Let's say you want to change something in the checkout. Let's say you have a new icon or a shiny button or a different way of processing checkout. When you deploy the code, the else block is still used. But one fine morning, when your team decides or your product manager decides that we need to enable this, they just change the configuration in some file or in some database flag. You don't need to have the new code. The new code is already there. It is just not used. Then the new checkout flow will be from false to true, and this will start executing. And even this gives you a advantage of you would be able to roll it back without reverting to the old version of the code. You can just say new checkout false, in that database or configuration file, which is independent of your deployment. And then uh, you just go back to the old flow. When the, let's say the campaign is over, big billion day is over, or there is a problem detected, you can always roll back. And even more safer way is to do a canary deployment. For example, let's say you only want to enable the big billion day for prime customers or a very small set of customers just to test that if it works or not. Let's say you want to enable only for your employees, if so that internally it can be tested. You can do that. Only 100 people or 200 people see that, and then when you are satisfied that, okay, the feature is working, let's enable it for the whole world, so that you have a confidence that nothing is broken to the whole world immediately and they start complaining about your product. Then let's talk about testing. Unit tests are the most popular kind of test that you can do. There are several things like integration test or deployment test or synthetic tests. So unit test is the thing that you write most, but there is always a notion that more the coverage is better. It is true in general because the lack of coverage shows that you don't have much of the unit test, but having the coverage is not sufficient. Let's say you have 80% coverage on your test, but the quality of test matters here. For example, here you can see somebody is trying to test a private internal method, which has some logic, but it can change tomorrow. And the test will start failing, although the logic overall functionality remains correct, but the logic is different. So you have to always test the functionality, pretty much public method or protected method in case of Java, if you want to enable it for the package only. And when you are testing something, for example, if you test just assert true or false, it could be true for any reason. So here, there is no message why it is false. So when the test fails, it doesn't give you a message that why it fails. It just said that, okay, this test failed, go and debug. Then you spend a lot of time. But a good test will always uh, not only check the specific value of the method that is being returned, but also will probably have a message that why this value was expected and not matching with this value, go and change, go and fix it. So uh, a good test is always fail whenever the logic, the actual main code's logic is corrupted. A bad test will continue to pass even after somebody messed up the logic, and you will never know. So one of the best practices is test-driven development. So you basically write the test first and then write the code. For example, here you can see somebody wrote a test. Um, yeah, so before that, so the philosophy is you write a test, it fails because there is no logic, then you make it pass, and then you write another, then you uh, fix the test, and then main logic fails. So you do a red, green, red, green. Red means the test is failing, green means it's passing. Then only you can add new feature. So one of the example here, somebody is trying to add two numbers. In step one, they wrote a test, add 2 plus 2 equal to 4. And it will obviously give error because there is no add functionality yet written. It's a compile time error. It's not even a value error. So it's in a broken state. Then somebody came and tried to make this test pass. So they said, okay, it's 2 and 2. Let me hard code it to 4. Now you see the problem here. The test passes. Now next step is you try other combinations of input. So you don't give 2 and 2 anymore. You try 2 and 3. Now the test fails again because 2 and 3 is not 4. So if you did not do this, you will always, you might end up writing a logic which is passing for a single set of input, but is not generic enough, which is covering all the range of input. So you next time you fix the logic such a way that not only the old input, but also the new input is uh, being handled by the logic. So that's the advantage of test-driven development. And the good thing is at the end of writing a code, you already have the test. You don't have to proactively go and write tests to protect your functionality. So the number one reason you write test is to make sure you basically avoid regression. Regression is something, a functionality was working, then it stopped working suddenly because you added some more feature. So more and more you add features, the test suite is actually a safety net for you to make sure that old features are still working. So beyond writing code, you always have to take care of the security and privacy also, because in a software system, your user is not very knowledgeable. They can accidentally mess up the system, or there are attackers, bad actors, which can also uh, deliberately try to game your system and take down your software, or maybe your reputation is at stake. So you always never trust what the user is going to input. There is something called SQL injection. So if you just concatenate the string to create your SQL string, they can smartly add another SQL in an input instead of text, instead of raw text, and end up having your data deleted or inserted garbage value. So you can do two things. First of all, make hard input validation. If it's a string, it has to be a string. It cannot have numbers or anything. If it's a value from 1 to 10, it has to be a value 1 to 10. They cannot give 1 million. If it's the age, you don't allow 201 as an age, right? So you have to validate. And also there are techniques to parameterize the SQL queries. You can use some libraries to have prepared statement is one of the Java library that uses that avoids SQL injection. The least privilege principle is whatever your code needs to do, it should not have more than that privilege. For example, a very simple thing, you have a flow where the data is a reporting service. Let's say it's reading some data from database and it's showing you the numbers. So when you do a database connection, that connection doesn't need to have a write privilege. You can use a different user who can only have a read privilege. Because if by mistake somebody wrote some bad code, instead of select statement they put an insert or update, even the reporting service would start corrupting data. So it should always segregate whatever is needed, that only should be given the privilege. Let's say you are writing data and the end user doesn't need to write the data. It's only for administrator to write the data. You can have a separate API, separate data connection, which has a higher privilege, but it will be hidden under some permissions. Similarly, like your database is storing data, but uh, let's say the system is down and some attacker gets hold of your database. So your a component of your system is compromised. Then you don't want the data to be out. So uh, you probably have to take another example. You have a system and you have a lot of logging. So you have uh, a bunch of text file that is getting generated. If that logging is in a different system which gets leaked, then a lot of people can get hold of the email IDs and personal user or Aadhaar number or whatnot. So whenever you're dealing with this sensitive data, you always sanitize. You should scrub this information with some random ID or a hash or anything, so which is not identifiable. Uh, let's say if somebody gets hold of the log file, even your employees, let's say there is a bad employees in the company who is trying to read financial transactions. If they see the username is XYZ and the PAN number is some random number, it works for you, right? Because then it doesn't know what is the financial statement of whom. Only the runtime system can translate that user ID to a name XYZ and show you in the portal. So always have the personal information sanitized. And obviously, encryption is the way so that the data which is stored in your disk or a database is encrypted. So somebody get access to the database, they cannot read the data. Only the program can read the data. That is encryption at rest. Encryption in transit is HTTPS is one example. When your data is transferring from browser to your server, HTTPS encrypts it on the way. So that if there is a person in the middle intercepting the traffic, they will not see the plain text going. They will see some garbage going. Only the sender and the receiver has the keys to decrypt it and make it useful. So I'll just move a little bit of fast. We are almost time. There is this slide is more about when you are having a system which is distributed and you are having a big team. It is not humanly possible to create the jar files or the Docker images and deploy manually. You should have always a build system. So CI and CD. CI is continuous integration and CD is continuous deployment. So CI is the part where your code is converted to artifacts, jar file or image file, which can be deployed. So as and when you enhance your code, check in new code, it automatically generates those files. I think things like Node.js, those are just bundled. They are not compiled, right? So they would go as it is. But things like C++ or Java, they get transferred to some classes, an exe file or any binary file that is supported by the system. But then at the time when you decide to deploy it to server, that is CD, continuous deployment. You don't build the code all over again because your code is getting built and these jar files are getting created over and over. You just decide which jar file should be deployed to which environment. You deploy to stage environment. Stage is basically pre-production. It's basically where you test right before you go deploy to production for internal testing because it behaves exactly like that. And then you deploy it. And if you have to roll back, let's say move to the previous version, you don't revert the code, build it again, and deploy it again. You basically just deploy the yesterday's build because yesterday's build did not have this corrupted new file. So you keep a last 15 days jar file, and you can always go back to any of those last working condition, right? So there are several ways. You do not want to deploy everything all once again. Let's say you have a bad code and your system goes down everywhere. So rolling update basically tells you is a strategy where you basically replace, in case of distributed system, you have multiple instances, right? So it's not a single server that is catering to the traffic. You basically only update one instance one after another and slowly go to the entire fleet. And similarly, the blue-green deployment is when you deploy the new version of a software in an instance, you start diverting the traffic slowly to the new version. And if it's working fine, you divert all the traffic to the new version. If there is a problem, you go back and divert the traffic to the old version. This basically expects that during deployment, you have a old version of software and the new version of software running parallelly, and you play with the traffic. Where should it go? If the new version works, then all the traffic is going to the new version, and you can delete the old version. So at any point of time, it's kind of safe that not that your old version is updated to new version, and now you have to create the old version again, which takes 1 hour, and users will be down till that 1 hour. And canary release, we already discussed. You first start a small percentage of user to be in the new version so that they are the guinea pig of the new software. And if there is a problem, only certain users. It's very unfortunate for those users, but it's not everyone who is having a problem. From those small number of users, you can predict that the software is working or not. Because sometimes the same code is working internally because you did not expect what the actual production users are using. And observability is nothing but monitoring. You are already familiar with logs. You have a log in every important line of code so that you know that how the control got executed. Then you have to also emit matrices. If your server is healthy or not, you have libraries which can emit metrics like CPU, memory usage, and everything, so that you have an idea how much health your production service is having. If your CPU is too high, then you know that you need more servers. Or if your memory is too high, then you might have a memory leak problem, which is allocating memory and not deallocating it. So you might have to look. But having these metrics and logs without having all these metrics and logs, it's basically you're running blind. You don't know where the problem is. You just know that users are complaining, their website is not loading, but you don't know what is the reason. Is it the error increased? Is it the memory increased or CPU increased? You have no idea till you log into the system, and sometimes even then you don't know because it's a distributed system. Traces is one of the very nice way of knowing the history of the request. So where the performance bottlenecks are. For example, if a request can take 5 seconds, but from the traces, you know that 2 of the 5 seconds were just taken to read the DB query. So you know the problem is nowhere else, but only in the DB query. So you need to optimize the SQL or probably increase the database strength. So traces give you the breakdown, what part of the code spent time where, so that you know where the problem exactly is this. There are a lot of libraries for distributed tracing for this. Even if it is not a single system, it's a two different system, you can propagate the context of the trace to one system to another, so that there is a whole chain of request that is visible to the administrators. So this diagram is basically sums up in a typical distributed system. You have a API gateway where all the requests come in from your mobile device and client, REST client. It can be web, it can be it can be some other service calling you, and you have a load balancer, and behind the load balancer you have independent services which is catering to you. So typically in these kind of distributed system, you need your logs to be unified and uh, stored in a central place to be queried, because you cannot log into individual instances and check the logs, right? Because the problem may be some one of the hundred instance that you have. And service registry is a concept where you discover where the service is, because when the request come in, it doesn't know which service, what is the URL of which service. So service registry is something which is consulted at the runtime, and you know what is the URL of the next service to call to. So because this is one of the important thing that lot of companies, even though they are building commercial product, they rely on open source technology because of these factors. Because once the technology is open source, there are a lot of contributors and uh, active participation of contributors takes the software to the next level. If it is not open source, then only a limited set of people can contribute from that company, and it doesn't grow. So, and also if it is open source, the source code is visible to everyone, so that the security analysts can already see that transparently if there is a vulnerability checked in or not. If it's a proprietary software, you cannot guarantee that there is a vulnerability that has been checked in. You have to blindly trust it. And because open source technologies are battle tested, for example, if there is a Postgres, you don't want to write your own RDBMS, because PostgreSQL covers most of your use cases and it's free, and the only cost you have is probably to host it. So, and when it comes to the hiring and employees and developers, a lot of people are familiar with Postgres open source already. So it's a win-win situation. The employees and the developers get to work on a technology they are familiar with, and the same learning will be useful in the next company or next software they build. And the companies get people who are very good at the software they're trying to use, right? If it's a very proprietary and nobody use, then it's very hard to train and master those technology. So you'll see a lot of big companies like Kubernetes started at Google. Now it's a part of Linux Foundation. Then React is probably, there's a React Foundation as well. Kafka started in LinkedIn. Now everybody uses Kafka. It's part of Apache Foundation, and it has been the standard for any real-time streams or pub/sub technology, right? And PyTorch, probably number one software when it comes to data science and analytics. It's also open source. This is the last slide. And with all this knowledge, the paradigm is shifting these days. It's probably very new to even the experienced software people, software engineers like me, because last 6 months, last 1 year ago, probably I was not using any AI tool to code. Now I'm using all the AI tools to 100% code, be it Copilot or anything else. So the way you write the code is changing. And by the time you start building professional software, or if you're probably already doing it, you will see that writing code by hand, line by line, is no more the day-to-day thing. You write in a way that you just decide what to be done. You give the enough details to the AI agents, and it writes the code and tests for you. So you spend more and more time planning it. So literally, there is a mode called plan mode in IDEs like VS Code and Cursor. So there, no code is written. You just plan. It creates a MD file or a bunch of text, exactly enough for agent to create a code which is accurate. Because the more time you spend in planning, it gives you feedback what it is going to generate. Once you're happy with it, then go ahead and uh, let it generate the code. And if there is a problem even then you change the plan. You don't change and fix the code manually. In ideal condition, you change the plan such a way that next time it generates somewhat better code which passes more of the tests that you might be doing. Okay, that's all for now. I think there's a Q&A session as well. Correct me if I'm wrong. I'm not really out of time, but you can reach me in email. That's the most thing. I'm still a very old school email person. I check all the emails and reply. And otherwise, there is always a LinkedIn and Twitter. I still call it a Twitter. You can reach out to me, but don't expect a lot of gyan there, because Twitter is reserved for all the rants about cricket and other things. But yeah, it's a good place to connect and hang out.
Thank you so much, Neil, for that. I think they have learned a lot. It's the era of vibe coding. I know most of them are using cursor for code, but the core concept remains the same. One such core concept topics was delivered by Neil today. So I think you have heard, I have learned a lot of things from this session. Feel free to drop your questions if you have. So Neil have very broad knowledge on cloud, software engineering, or if you have anything related to technology, AI, feel free to ask to Neil. Um, so the chat is around 1 minute on 1 minute latency. I will wait for others to put their questions. So guys, if you have any questions related to this, please put it in the chat box and I will take it one by one.
One of the call out is that due to lack of time, I think the principles like solid principle and dry principle, those are covered very quickly. But there are really, really good books like Clean Coder by Bob Martin, I think. That's a very good book that I was introduced to earlier. And it has some real world examples which you can connect with. So it's very good to read.
Clean
And
code, Robert Martin. Yes, yes.
yes. So I call it Uncle Bob. So it's like a Bob Martin. I was confused. And the good thing is, all his lectures started with astronomy and then slowly moved to the software engineering. So both best of the both world. And there's a question called vibe coding, if is considered security. Yeah, vibe coding is a very infamous term, right? I think it was introduced by somebody called Andres Carpathy. So yeah, so the definition is not super clear to me, but I find vibe coding is when you are interacting with the chatbot a lot and just letting the code gets generated on the way without even understanding. all you are interested is your output is correct or not. So I was actually developing an app, a couple of app I can. It's in my Twitter. So I was creating an app for showing the date and time, tithi, and all the astronomical planet position on a web page. It's called stargazing.web.app. So I did a vibe coding actually because it's not a production grade app. I just wanted to have fun. So if you overlook the mechanism of it or the code it is generating, or if you don't plan it for upfront and then let it generate, so you might already miss a lot of things. Like security is one of the reason, and scale. I think it's good for having POC demo or a minimum viable product. Not so. It all depends on the definition of vibe coding. If you're not testing comprehensively, just creating the UI and by chatting back and forth and checking the UI is rendering or not, yes, vibe coding is bad. Versioning disparity works like you telling in versioning part, how it maintains its stability. I don't know exactly what's the question. The what I understood is if a new version of software is not compatible with older version of another software, is if that is the question, uh, then yes. I mean, I can give you a classic example of API contracts. So let's say there is a service A calling service B. It has an API, it calls with 3 parameters. Now they deleted a parameter, and now they start calling with 2 parameters. You never do that because the if the consuming service do not upgrade or change according to them, it will break. So you should be always backward compatible. You always add parameters or add attributes. Even if it's something unused, you let it be there. It might become a lot, but it's always guarantees that there is a backward compatibility. So whenever you're changing something, you make sure that the older version of client who is calling you is compatible with it. So backward compatibility is the key. The only problem happens when there is a database schema. So you never drop a column even if some column is unused, or you want to rename the column. That's a bad idea. You always add a column and change the logic to talk to the new column, because dropping a column, your old code, suddenly a machine which doesn't have your new code will try to access the column that was renamed or deleted. So always go for backward compatibility. How can you use AI IDE that exists like cursor? Do I write framework that fills up gaps with AI, or I tell AI to? So is if the question is about uh, just letting the AI go through your code base, which is an existing code, not a new code like a greenfield project, and figure out. It's a bit tricky when AI is used in old code. The way I use AI tools for old code is to explain the code first. It may not do a very good job if the code is wrong or there is a gap. It might give you some feedback, but it's very good at explaining older code. But if there are enough tests, then only you can catch the problems. But uh, if you really want to plug the gaps that has been there older, you have to be smart uh, in prompting. So somebody said, if you can describe the problem, it can do. So if you can describe what are the kind of direction you want to search the gaps, it can probably find the gaps. So we very verbose and intentional. A bad prompt is go and fix the gap in this class. A good prompt is check in this class all the validations are done or not. So you have to be really elaborate. So the context, like it is said is really important. So I think the field is getting renamed to context engineering rather than vibe coding. Vibe coding started in a fun way, but context engineering is the new term. And also, it's very one of the emerging field is to how to manage the context, because when you chat for so long, uh, you might have noticed some of the ideas compacts the chat because it cannot retain, like human memory, it has limited memory. So it so either you tell that, hey, in chat window, can you summarize and only keep the key points, do not uh, and start the conversation again, because it gets slower and slower and then it misses some of the points if it's out of the context window. So managing the memory and context window is important. And I've seen things hallucinating also. For example, um, I was writing a product, not really for coding. I was writing a product. I have a app called, this not a kind of a self promotion. It's just a fun web app. I put it. So you have to give a bird image, and you have to find the translation for the regional names. For example, uh, white-throated kingfisher uh, is a bird. So when you ask the Indian name of it, it has hallucinates sometimes and says that the literal translation of white, like safed gala and all those things. So this is not a real name of the bird. So yeah, thanks for correcting the link. This is not a real name of the bird. So in the prompt itself, I had to explicitly say that avoid making of names, avoid literal translation, don't add new facts. So these are the keywords I have to add so that it doesn't hallucinate. So you have to force the model with the prompt that it doesn't make up things. This is one of the way I have found. Hackathons, I think, yeah, you're right. So hackathons, definitely you should get started right away, but you should have a overall knowledge what you're going to build. Uh, what's Because in hackathons sometimes you don't know what technology will work and what will not. So if you, like, we recently have a 36-hour hackathon in one of the colleges. So on at the end of day one itself, a lot of people were just thinking what to be built. So if you have somebody already deploying a hello world application and figure out what is the end-to-end deployment looks like and then iterate on the business logic, that will be a great thing. So yeah, this talk is all about professional software building in a team which somebody is willing to pay. Learning new technology, I'm not really a good reader. As for any technology, I was always forced to use it. So anytime I join a new project, there was a new technology, I was forced to use it. But proactively, when I try to learn something, it needs to have a real differentiator, because I went and learned Go because somebody said concurrency is really great in Go. It has a first class citizen. You don't really need libraries and everything. So I learned Go. But then when somebody said go and learn Rust, it's cool. But then I never got a motivation for it. But rather than programming language, I think if you're good at any one language which has most of the features, then learning patterns and design patterns is a great, yeah, design pattern is one of the aspects you should always read books and find. But learning a new database just for playing with it, I have never done it unless it is used in the project. There was a time when rdbms was not an option. I we needed to have JSON data. So then I learned MongoDB and everything. Then we realized that PostgreSQL already gives a JSON field. So we have already tried to extract most out of the existing technology, because changing technology in an existing software is very hard. but yeah, there are good uh, engineering blogs for a lot of companies. Like Netflix itself does a lot of engineering blogs where they post things when went wrong, like post-mortem reports, what happened due to the downtime. You must have heard Cloudflare downtimes recently. What happened to the DNS outage? Those are sometimes very interesting, and you get to learn new technology terms in that, and then you take that and Google search it or and find out more about it. But I think it's really, really important to have very good, be good at a single technology, because even in interview I've seen they give you a specific choice of your language in a lot of big companies, even if you go ahead. I worked on Spring Boot, Java a lot. I've done Node.js, not so much of Go and Python. Uh, so that's exactly what I was talking. It's very hard to say what is the best stack, because if you see the number of software that exist in Node.js, Go, and Python and Spring Boot, probably equal. So nobody, if they were the best, everybody would have used it. So for example, Spring Boot is really, really great at abstracting a lot of complexity of model, view, controller, all the web things, which Node.js gives you as an express, but you have to import a lot of. If you're a JavaScript developer, for example, Node.js is probably a piece of cake to learn. So a lot of front-end developers, when they learn, they like to learn Node.js as a server technology. And Go and Python are totally different. If your company has a lot of data science and AI fundamental programming, then Python is the way to go, because why to use two different skill set? Use Python for server, use Python for AI, data science like pandas and all those things. So one language solve all the problem. You don't need experts from different domain. And if you're writing something scratch, a lot of people go for Go because uh, their performance is really, really good, great. So it depends in which situation your project is in. If it's a greenfield project, probably you will never go wrong by choosing any of this technology. There is always something in each of these technology which covers for the others. Uh, Worst case, you probably have to write a library for it. Just for one library, you don't choose technology, right? And yeah,
Cool. Um, I
did I
think
miss?
no. I think one question regarding. I think we can take that question offline, Akhil and Pushpit, because we are totally out of time. Maybe next time we can take those questions. Sorry for that, but yeah. Um, cool.
Sure.
Thank you so much, Neil, for joining. I think they have learned a lot of things. Guys, if you have any questions, feel free to reach out to Neil. If you have any questions related to photography, feel free to reach out to Neil. Or anything related to programming, please reach out to Neil. Uh, so I will also ask Neil to take a session in future.
Sure.
Since this cohort will be running for 2 or 3 months, maybe on the next day, if you have any questions left, we can also take those questions on the next session. Cool. I will hop to my slides.
I'll just release it. Okay.
Yeah, yeah.
Yeah. Thanks, everyone. Thanks for the opportunity, Ankit. It's really privilege. I think there's almost 100 people were there. And I know it's a bit fast paced because of the server technology, distributed system, programming fundamentals, everything. But feel free to just remember the keywords, look up, just motivate yourself to learn more.
I think these are the things that will only help them in while in placements. They will remember these few things
Yeah.
and these lessons in placement. Yeah. Thank you so much, Neil, for this. Cool. Let's go to the next slide. We have Sanskar with us, who is an AI engineer. He will be talking more on two systems on Wiki that we have. That is Toolforge and PAWS that we have. Yeah, Sanskar, is it audible?
Yeah.
Yeah. Cool. Go ahead.
Let me present the screen. Okay.
Sanskar, let's keep this short. And
Yeah.
then we'll go ahead with that. Yeah.
Yeah. Okay. Okay, all right. So thanks for the introduction, sir. And I hope you guys have, understand all these technologies from our past few lessons and sessions. Okay, so I hope you guys have some ideas about these projects. And let me ask you guys, do you know these projects are hosted somewhere on the cloud and all? So anybody who is here in this call who have hosted their websites, servers, or anything like that, scripts, what like give a reaction like kind of that, so that I can understand how many of you have hosted any of your projects. Okay, okay. So I can see a lot of you guys have hosted your projects, and actively running those projects is something very important, and for the production grade things. Okay. So now we have some two important tools today, that is tool forge and pause. So what does these tools means? By the end of this session, by my session, you will understand all the requirements and what these tools will help you scale your production grade application and web apps for this Wikimedia ecosystem. So let's start and deep dive into it, and let's start with the tool forge. Okay. So before I uh, if I say tool forge, okay, tool forge is something where we can do and host our projects or over Wikimedia ecosystem. Like for example, if we have something like an bot or an website which is related or interrelated something into Wikimedia ecosystem, or supporting its other projects, or creating an ecosystem where people can come and collaborate, and in an open source environment, we can do it all for the tool forge thing. Okay, so I have used recently buy subscription over Hostinger, that cost me around 10,000 rupees for an year. Okay, that's something really very costly for an student. But if I am contributing into Wikimedia ecosystem, I don't need to pay at cost, at any cost, and like I can manage all those things with Toolforge admin consoles and manage my workforce. Okay. So before using Toolforge, we have to follow some terms of uses, because it's an open source thing, and you are doing something and contributing into an ecosystem where millions of users are daily using something. Like Wikimedia is the biggest platform for information. So like you have to follow some rules and set of policies which is set by Wikimedia organization. Okay, so we have, so first of all, we have to choose only Wikimedia related processes, projects and all, as I told earlier. Then we have to keep secure, no plain text and secure. We have to, do some monitor logs and all those things, because as Neil sir has already defined that logs maintaining and contraction of the code and all, it's very important for any developer and who is developing anything for the production grade thing. Okay, so we even have to avoid heavy job roles. Like for example, there is a major call over the database, and that will impact the other projects as well. So we have to be use all these open source things in a limit, and we have to use the best practices for all those things for catching and all. So so we have to even limitize the API uses as well, because it's an open API, because Wikipedia provide every API as an open API for use. Anybody can come and use those things, but you have to you have to use some rate limits, so that you can you don't be get flagged by Wikimedia moderators and maintainers. This is very important thing, and you have to follow these things, and you have to follow a code of conduct that is mentioned in the documentation part. You have to use all those things, and be at a safer place. And make sure you have to write a clean readme file before uploading any project into Toolforge, because readme file helps the maintainers and the moderators to get insights about your projects, and they can now validate your projects as a good project or a bad project for the Wikimedia ecosystem. Okay, so maintain a clean readme file and avoid publishing your private keys and secret keys into the public repos. Okay, make them in a separate things. So here are some of the examples which we have, which we can say which type of projects can be deployed into tool forges, and which are disallowed on exposing into tool forge. Okay. So first of all, we have running a read-only analytics script on public wiki data and all. So this is something we have seen WikiNav thing, where we can see all the analytical things about wiki data. Okay. So after this, I guess there is a question or something. Okay, sir, have texted. Hosting a small dashboard showing page view, trends and all. So we can do things like this, but make sure it's something related to Wikimedia ecosystem. Scheduling a nightly job on a databases and then deploying a public info pages that list purposes and maintainer codes. Okay. And some of the projects which are disallowed on Toolforge is something you cannot use anything that is for the commercial use, because it's an Wikimedia ecosystem based tool. So we have to be focused over some of the restricted things. Okay. And we don't need to leave plain text passwords into the public repos and all those things. Apart from this, we have some of the examples which are real world projects which are hosted on Toolforge, and we accidentally or by knowingly we use them on for our work. And this is something what we say is WikiNav. First of all, is WikiNav. WikiNav is a tool which use to visualize how you shift over some articles to the articles. Like for example, you are reading an article, you are reading some hyperlinks, and you clicked on it, and then you visited another page. And this can be shown into a trend like graph, and which can be done using WikiNav. You can use this tool. This is a very interesting tool. After that, we have page views and analytical things for counting how many page visits and all those things we have on our platform. Tools Hub, I already explained it in the previous slide. That is, we can store database and things all over into Tool Hub things. Okay, then we have Fountain. Fountain is something and a project like an Power BI, where you can use dashboards for showing set of datas. Okay, then now let's come into Pause. Pause stands for a web shell. This is a Jupyter Notebook development hosted by Wikimedia. When I called Jupyter Notebook, I hope many of you guys know about Jupyter Notebook. Let's see how many of you know about Jupyter Notebook. Like, give me some reactions. Yeah, I hope all of you have used it in college and everywhere. In the projection and development of your college life. Okay. So Jupyter Notebook and Pause is something very similar thing, but it's something Pause is developed over Jupyter Notebook on a Jupyter Hub. So it's kind of really very different from Jupyter Notebook, as Jupyter Notebook is an open source tool that allow users to create and share documents that contain live code. Likewise, we can use Jupyter Hub for like Jupyter Hub as in Pause for Wikimedia projects. Okay, so why we use this thing? Why just Pause exist? Okay, so for this we can understand it as Jupyter Notebook is a single user and self-maintained thing, and Pause on the other hand is shared, hosted and Wikimedia ready. Like you don't need to set up PyWiki bots. It's already set up there. You don't need to set up dependencies and all. It's already set up there. So it's kind of an Wikimedia ecosystem where you can find each and everything related to Wikimedia, and you can get out into one place where you can manage your teamwork, manage your you don't need to manage about hosting and all, because all the servers and maintenance is done by Wikimedia organization itself. So you don't need to do a lot of things, and you can start practicing your code. Okay. So there's some simple comparison which I generally told you guys. So it can, Jupyter Hub requires some of the browser settings which we can use it into Pause. we can use it into Jupyter Notebook as well, but you need a lot of installation, but in this you don't need any installation. And you have this is very important, PyWikibot ready. This is an inbuilt feature which pause provide us, and server maintenance is maintained by Wikimedia managers. Okay, so this is it, and we have now pause and Wikimedia has. So now come to the terms of uses for pause as well, because if we are using anything which is open source, we have to follow the rules and regulations. So it's again something, it should be Wikimedia related processes and projects and all. You have to follow all the laws and Wikimedia policies, and do not misuse or overload the system. Do not collect प्राइवेट यूजर डेटा. विकीमीडिया सस्पेंड टूल्स, अगर आप ये सब चीजें ब्रेक करते हैं, सो विकीमीडिया विल डायरेक्टली सस्पेंड योर अकाउंट एंड ब्रेक and terminate you from using Wikimedia tools and all. So there is an advice while using ToolForge or pause. Don't use your exact and main Wikimedia account, because you might get flagged even if you have a good purpose of doing work, because sometimes the moderator doesn't understand, and at once they flagged your account and you might get banned. So please don't use your direct main account directly into these technologies. Okay, use a bot accounts. Okay, now we are into my last slide because we have to wrap it up super early. We have some practical things as well, but I'm skipping it for now. So like there's a difference between pause and ToolForge. So pause is something which is best for practicing, learning, experimentation, ideal for workspace and training, and we don't need any setup kind of things. And this is something for an exploratory work. Okay. And on the other hand, ToolForge is something best for production level tools, long running services, bots, websites, dashboard we can create on it and you can host on it, and which can be seen by a lot of people all around the globe. And this is tools used by Wikimedia community, so it's all required Wikimedia related ecosystems to be hosted on these platforms. So on one line we can say pause is for the practice and ToolForge is for the production. And that's all. If you guys have any question for this short session, you can ask me, or you can write it in the text box.
Cool. That was very interesting, Sanskar. Thank you so much for that. Guys, if you have any questions related to SH's key setup, or if you have any questions related to ToolForge, I wanted to give this a short intro about ToolForge and pause, so that tomorrow, if you're using these technologies, you should know how to use these technologies. So if you have any questions related to that, please put it in the chat box.
Even after the session, you can ask me on the groups. I am already available on the group, and you can ask me directly on my DMs or on the public group as well. You can ask me anytime, anywhere. Okay.
Cool. Let's see if there is any questions, Sanskar, or we'll move to the next slide. Let me share my screen.
Yeah, it supports everything, but make sure it's something related to Wikimedia ecosystem. It's exactly similar to your DigitalOcean, AWS, or something like Finger or Vercel kind of things. It give you an exact environment of all these technologies, but it's specific for the Wikimedia processes.
Yeah, but do not host your personal project on ToolForge. So please feel free to take help from Sanskar or any mentor. We will be assigning a mentor to you. Feel free to take help from mentor before hosting it directly on ToolForge, because you are very new to the ecosystem. So please wait for that. We will be assigning some mentor, and then you can use it.
Kanhaiya, you can use ToolForge to publish your own personal project, but it should be maintained and approved by Wikimedia officials and the maintainers of ToolForge. You can mail them using you can use Garrett for this. You can search out their name and you can get out the email ID of those persons, and you can even search it on LinkedIn as well. and you can ask permission, and then you can showcase your project, and then you can publish it on Toolforge. And make sure you use bot accounts. Okay.
Yeah. One thing, Sanskar, just to add to Kanaiya's question, guys, as of now, don't do that. Feel free to connect with Sanskar or any mentor under their mentorship, then only do that. As of now, don't do that for your personal project. We have a lot of others platform that you already use for your personal project. So please keep using that. As of now, don't use tool for directly to use your personal as a personal project. Cool. The main motto of this session was to give you uh, self explanation on Toolforge and PAWS, so that in future we will be using these for prototyping and making tools and gadgets, so that you can understand what it is. Cool. Let's go to
Thank
the
you.
next slide. Cool. I will be asking a short question to you guys. So there are three clues. This software is famous for being able to play any video file format in this world, even the broken ones. Clue two is it is open source, and third, let's see if you can guess this. And its logo is bright orange. So let's see if you can guess that. Yeah, it's VLC. Cool. I think that's correct. It is VLC. Um, so if you see the story of VLC, it wasn't built by a billion-dollar company. It was started in 1996 by students just like you at the University of France. They were building a network. They were basically building a network project. And one night, the student came back from a party, and they stole a traffic cone from a road. They kept it in their computer lab. When they launched the software, they made the stolen cone as an icon, just as a joke. And today, that student joke is, or VLC Media Player logo is downloaded 3 billion times, and it runs on Windows, Android, iOS, Linux. So if you see these massive open source project are built by students as their side project, and they just grow massive with time, be it Linux or VLC, any such open source project. Uh, so these were built by just students like you who are doing right things at the right time. So this is one of a kind that we are doing in Road to Wiki program. Um, cool. As you know, guys, we will have some holidays in this weekend and next. So let's utilize this time of session as the time to catch up. Make sure you activate your Fabricator account, set up your SSH keys, go to, we already have shared PPTs and resources and recordings. Please go through those recordings and PPTs. Ask your questions in group. If you are stuck, please ask your question in group. They will able to ask, our volunteer students will be able to answer, because I really want to make this community as a peer learning community where you learn from each other and you collaborate with each other. If you're getting stuck, if you have a error, please post it in group. Our community will respond, and this is how the peer learning works. Document it well. Take a screenshot. Um, what error you are facing. Let's post it on X or LinkedIn, because documenting and putting it in public is very important in tech. Post it on LinkedIn, X, and about the screenshot, about the caption, about the error you face and how you have overcome those errors. Um, for example, spend 2 hours fighting SSH key permissions for Road to Wiki program, but finally got a handshake. Working open source learning in public. So feel free to use this hashtag, and don't forget to tag us in this week-long holidays. Cool. Thank you so much, guys, for joining. Keep learning, and if you have any questions, feel free to put it in the group. We will be able to answer those questions. Cool. I hope you'll have learned a lot of things in today's session, and we will be doing next session after a few days. We have kept this time off intentionally to keep you learning and activating your SSH keys, so that you don't fails to do that. And once we come back from that, we will be doing another few sessions with experts. This time we will be focusing more on wiki concepts and how wiki runs behind the internet. So we will be talking more on that. Cool. Okay, guys, thank you so much for joining. I hope you have learned a lot. Keep learning, keep coding. Um